Hello. First, I want to say thanks to Matosin for putting this on. You guys are awesome. So, So this has been a great conference. I've really enjoyed it. Really happy to be here. I'm Alex Miller. I work on the core team. Rich and Stu say hello. They're happy I'm here as well. How many people here are using Clojure full time? Yeah, that's cool. How many people work for a company that's hiring? So yes, sweet. So it's great. I mean, I think Clojure is doing great right now, and don't be persuaded otherwise. Sometimes people pop up and say things like it's, who's doing this Clojure stuff? Lots of people are doing this Clojure stuff. So we just had a Clojure South. They've got like 500 people at Newbank doing Clojure right now. There's tons of people doing Clojure. This talk is it's kind of, I had several ideas, so I just mashed them all together and made a lessons learned talk. So it's a little bit of a grab bag, but it has a bunch of my opinions in it. It's about things that I think work. And because this is a keynote, you can know that I'm right. You don't have to question anything. If you saw Dave's talk earlier, I'm not a social scientist. This is a sample size of 1, but you can just trust that it must be right. And Jack said earlier to take some mushrooms, so I did that. So it might get a little weird by the end. I don't know. We'll see. This is me as a kid when I started programming. There's a lot to soak in there. That's a great picture. There's a lot of fine details in that picture. When I was about 7 or 8, something like that, I took a computer class on the Apple IIe's, learning Apple logo. So this is where I started, and it was a great time. And I actually found an emulator for this and went and wrote a few little things when I was doing this talk. It was fun. Brought back a lot of memories. There were a couple lessons I learned from this. After I took that summer class, they actually got some Apple IIe's in our school, and I actually helped set up the lab because I knew more about it than the teacher at that point. We kind of learned together. But one of the things Apple logo had, in addition to all the turtle graphics stuff, was the ability to make sort of text interfaces, so you could ask for input and put things on the screen and do that kind of stuff. And I made this elaborate quiz about the difference between crocodiles and alligators, which took me probably a month to make. And it got so big that I actually, there was too many questions to actually fit in memory at the same time. So there was actually the facility in Apple logo to dump the memory and load a new data file off of disk. And so you had to change floppies in the middle of the quiz. It's pretty advanced stuff. I was well beyond my teacher's knowledge at the time, and so the first lesson was read the docs. I read a lot of docs and learned how to do that. And I even later coined the Miller principle. Maybe you've not heard of it because you probably didn't read it, but this was in 2007, so I'm going to recoin it now while I have the stage, the Miller principle. No one reads anything. There were some other principles too, but nobody read them. So the other lesson I learned was that near the end of my work on this project, I had those 2 floppy disks with parts of the program on it. One was called Alligator 1, and the other was called Alligator 2. And in my, at the end of one tired day, I saved Alligator 2 over Alligator 1, deleting the only copy of my program, my month's work. So the other lesson was use backups. So make sure you do that. But I did a lot of, sort of evolved after that. Taught myself BASIC. We eventually got a computer, and I learned BASIC and Turbo Pascal and did some things like that. And then I went to the University of Illinois. And at the time, I was the most advanced programmer I knew because I was the only programmer that I knew. I had never met another person who did programming, really. And when I got to the University of Illinois, they were still doing structure interpretation of computer programs in Scheme on I don't even know what kind of machines these are. Next, yes, Next machines. It was like the future. I had no idea that such fancy things existed in computing. And I remember the beginning of that scheme course, and I thought I was like a programmer, kind of like I'd written programs to actually do stuff, and I got there, and they're teaching this scheme stuff, and it's all these parentheses, and I just remember the first 2 weeks I was like, I guess I didn't know what programming was, and that's not, this is actually real programming, so I don't know. And so I just gave up and just kind of surfed with the class after that. But eventually I got into other classes and I learned other languages, C and C++ and Perl and Prolog and more Pascal. I actually got a job doing Pascal in college, so that was my first paid programming job. And I did know about the demo scene. I was into that in college. Didn't do it, but I just enjoyed watching the videos. And then finally I got out of school and got into some real programming. My first job was at a company called LexisNexis, who's still around they do legal and news information kinds of stuff. And that first year that I was there, I wrote probably 40,000 lines of production C++ code, most of a couple products. One was basically the same thing as Google Alerts. One was about the same thing as Google News. The Google didn't exist yet, but so I did it first. So unfortunately, they had no idea how to market it. Those products died. But the best thing that I learned at LexisNexis was they had a really strict policy about code review. And so I wrote all this code, and any line that went into production got code reviewed. So I spent time every single week for a year and a half either having my own code reviewed by a bunch of other professional programmers or reviewing other people's code and commenting on it. And that is a fantastic experience. And so it's something that I think works. I still do it a lot. It was great training because when you get into open source, I spend a lot of my time these days reading diffs and things like that. So I read a lot of other people's code. If you don't do that a lot, it's great practice. If you don't do it at your company, I'd suggest doing it. Just go grab a little chunk of code, grab one file, and go sit together and talk about it. It's a great way to sort of spread company norms and learn practices and things like that. And one thing that I learned in all those reviews was, and have relearned over and over again, usually my fault, was to be sufficiently afraid of cleverness. So it's real easy to find a piece of code that has a big block of comments, and where they're explaining what you're doing there, or to use some clever Clojure metaprogramming thing to do stuff when you could probably just have repeated yourself twice or something like that and done something more obvious. And I have been, I'm sufficiently afraid of cleverness, so I write dumb code. I try to write really, really dumb code and stay away from as much cleverness as possible. But occasionally, you have to go reach for that. Eventually, as Richard said yesterday, I was hoodwinked by the Java marketing machine. That I was the prime candidate for that marketing. Had been doing C++ and was getting really tired of using, chasing destructors and seg faults and using purify reports and stuff like that to track down memory leaks. And so I just jumped whole hog into Java as soon as it came out. And actually worked at State Farm, the insurance company, trained me in Java, trained a whole team of us for 6 months, and then they decided they weren't going to use Java, so we all left and got jobs elsewhere. I joined a startup, and this was in the heady late 90s days. This is an actual shot of our office, so this is what high-flying startups look like in the late 90s. We did have a foosball table, which is not in the picture, but but it was, and this was actually in the frontage space for a steel construction company, so it was really cheap. But that company was Metamatrix, and I ended up leading a team building a multi database query engine, a full SQL query engine, a bunch of other stuff, which was fascinating, and it was a great time, and I learned a tremendous amount. And within a couple of years, I was running a team of developers and had no idea what I was doing. So it was doing a lot of recreational reading about trying to figure out how to do that and how to do software development in a way that's sustainable and helps you make good decisions and all that kind of stuff. And for me, the thing that I have found then and continue to come back to is finding some rhythm for a process. And that can happen in the small. It can happen like on an hourly basis. It can happen on a daily basis or a weekly basis. Some people have probably read the Inside Clojure journals I've been doing this year, which I've been trying to do on a weekly basis. I'm a little off that rhythm right now, working on this and other things. But for me, it's just finding that rhythm and then sort of grinding away on that rhythm. And Agile has a lot of that in it. I never really bit completely on any of the particular Agile methodologies, but I think they had interesting ways for me, new and interesting ways to think about it. I was taught in very classic sort of waterfall style things. I went and kind of looked up where the origin of the nose to the grindstone phrase came from, just as one of the many little random tangents while I was working on this talk. And this was too good not to put in here. So this was the first recorded use of this term. So the grindstone was you're grinding your blades and you get close to it, So I like the clean disfigureth their faces. I thought that was a great phrase. So that has no value to the talk. I just thought it was fun. Another thing I learned, did a lot of stuff with databases and worked in a lot of different domains, and human stuff is messy, right? So, and you come back to this over and over again, people have, things are ambiguous, there are exception cases, there's contradictions, anything with time or geography or identifiers or organizations, all those things, it's just full of exceptions and, things that don't make sense. And for me, Clojure is a language that really it has its strengths in being able to be flexible in that kind of way, and you can use optional attributes and things like that to get a hold of some of those little details. In particular, obviously, Clojure is very aware of time, and I think there's not a lot of other languages that are so explicitly aware of that. The whole epochal time update model for state, I think is very much time is explicitly encoded in that process, and you see it in things like Crux or Datomic, where we're really talking about time as a first-class thing, and it's really important to our applications, and it is important to our applications. It's crucial in almost every application, and then I also see it even in and this is maybe a little more subtle, but how is code going to evolve over time? Like as you build an application and then it continues to sort of, be modified and have new requirements coming in, all that kind of stuff. How do I deal with those changes? So things like Spec are really trying to look at, like, if I write a spec now, how do I make sure that spec isn't brittle and continues to be able to work with new code as we add new requirements and change things. And so I think this is kind of an underappreciated area where Rich has had a lot of really important influence. So that's all I want to say about that. And eventually I found Clojure. So I found myself joining a company in 2010 called Revolytics, and because reasons, I was able to choose what language we were going to work in and to help hire the team to do that work. So I had a lot of influence over what we were going to use. And it had to be a JVM language just because they had some existing stuff that needed to interoperate with it. And at the time, I assumed that Scala was going to be a great match for it. But I also was aware of Clojure through Stu Holloway. And so I thought, well, I'll just pick a project, to start with, a little small thing, it's some sort of data thing, and I'll build it in both. And just kind of, as I'm hiring people, I was bringing people on board, and some of them had seen Clojure before, or Lisp, or something like that. Some hadn't. But nobody was an experienced Clojure or Scala user. And after a couple months, we'd built up a team, and I kind of looked around, and I'm like, are you guys still working on the Scala version of this code? And nobody was. Like, everybody had just drifted into the Clojure one, and we're all enjoying it a lot more. And so we were like, well, I guess we're doing Clojure. So, we just dove into that head first and never had any regrets about that choice. That company eventually folded. The government zeroed out our big contract, and so that was pretty much it. But that was doing a lot of RDF and Sparkle and things like that. Doing, again, data integration work. So it seems like I keep getting into the data integration side. And at that point, I kind of drifted over to Cognitect, and I kind of called them up and said, I think you should have a position that is like working with the Clojure community. And I happen to have a lot of skills that are really good for that position. So you should probably make that position and hire me to do that. So, and this actually worked. So it did take a while. there was some time for that to all work, but that worked out well. So, and I've happily been there ever since. So I'm going to talk about some things on the communication side. Obviously, I probably have talked to many of you on Slack. I'm online a lot. Fortunately, the Clojure community is great. So I participate in a bunch of different communities. You guys are great. So it's really not that big a chore. It's not that big I had somebody yesterday said you must see a lot of crap or whatever dealing with doing with the people online or whatever. And I'm like, really, 99% of it is really good. So and really I enjoy it. So it really is not bad. It is occasionally bad. So sometimes you have to, the lesson learned is just you don't need to read the comments. It's fine. And it's okay to turn off your notifications and your apps and go take a walk. It's okay. So that's a healthy thing to do. But if you do read the comments, it's also okay to not respond to them. So maybe there's people in this room that I haven't responded to. Sometimes that's because I don't want to respond. Sometimes it's because I just didn't see it. So you don't know which, but I'm not going to tell you. But sometimes I just it's not worth it. But sometimes it's those late nights and somebody's wrong on the internet, and so if you do respond. Try to stick to facts and the tech and keep people out of it. And I think if you're doing that, like I'm always willing. It really doesn't bother me if somebody says, "Hey, Clojure is wrong about blah 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 blah, and you should have this and do that and whatever." Like that's fine. I'm fine having that discussion, and maybe you're right. So the part where I get upset is when people say, you're doing this because blah, 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 and where they start talking about people and their intentions, and that's usually where I start getting upset. But so I think this is generally a good approach to things. And if you haven't seen the etiquette page on Clojure.org, Clojure.org/community/etiquette, that's something Rich wrote long ago, a little bit modified. And I think that's served us pretty well in the Clojure community. And Stu did a talk on stewardship, no pun intended, last year, or maybe it was earlier this year. Within the last year, I would recommend that if you haven't seen it. That's a great talk. Another thing that I wanted to mention was no is temporary and yes is forever, which somebody said, and now I've forgotten who it was. But I didn't coin that or anything. But as you're making choices about sort of what we do in Clojure, there are times when we just decide not to do something, and it doesn't mean that it's a bad idea, and it doesn't mean that we won't eventually do it. It just means that we're not going to do that right now. And it's okay to do that, because otherwise you'll go insane. The internet is a denial of service attack on your attention, and you shouldn't let it do that. So you just can't do everything. That's important, and for us, we also are looking at a long time scale. So it's easy, in your own application to say yes to something and then change your mind and get rid of it later. But for us, we take the backwards compatibility thing really seriously, and if we say yes to something, we're saying yes forever, right? We're gonna keep that on, and it's not just it's not just that feature or whatever that change is, but also how it interacts with every other feature in Clojure and how it's going to interact with every feature in the future too, right? It's something like if you talk to Brian Getz about Java, like don't get him started about serialization. So that's yeah, I think maybe one of the original sins of Java or whatever. So it impacts everything, and so you got to be careful about those things. At this point, I'm going to take a brief detour. So this is another. I'm going to change topics and talk about Spec 2, but it's going to tie back into when I come back to lessons learned. So we've been working on Spec 2 most of the year, and that's really been sort of my primary thing that I've been working on. And it's taken a while, and that's because we're trying to do some new stuff, and we weren't sure exactly how we were going to do it all. So it's one of those things that just takes time to gel and figure out. And I kind of expected it to take most of this year. I'm hoping that we'll be getting to something released like by Conj or end of the year or something like that. So, but I'm not promising anything. So one of the big things, and this is the whole point of Rich's maybe not talk. That's a much longer-winded version of what I'm going to do in the next slide or two, but you should go watch that because he's much better at it than I am. When we want to talk about aggregates in Spec 1, that's really done with S keys, and that's a way of saying this set of attributes is going to go together. And the big thing that I think Rich considers a mistake is baking in the sort of required optional aspects of things inside S keys, because those things are really actually contextual. And so a lot of times I'm sure people using Spec have run into cases where you want to do something where you like have a request that you give to somebody and they fill in more data and give it back to you. And so there are actually two versions of that aggregate, the one that you gave away and the one that you got back. And they overlap, but the required and optional things might be different for those two things. Or you might have a pipeline of transformations that occur, and you're sort of filling in attributes as you go down that, or maybe even removing things. You look at like the ring request maps and response maps, things like that. So those are things that people have found a little challenging to spec well in Spec 1. And in particular, if you start to nest things, that's where it starts to get really hard. You can kind of work around it at the top level, but when you start getting nesting, it's very difficult to take all the combinations there. So the thing that Rich proposed in the maybe not talk, we have now built. And so Spec 2 has this notion of a schema. And a schema really just specifies a set of attributes that travel together. It doesn't say which ones are required or optional. That's something you're going to specify in a context. So the idea here is to sort of maximize that schema reuse. So a user has an ID, a first and a last name, and an address, and that address has its own set of fields in it. Schemas are also specs. This was not obvious. We kind of went through a couple different versions of it where they both weren't and where they were, and we've ended up with them actually being specs, and that's turned out to be useful so far, so I think that'll probably stick. It's kind of like S keys, but with all the optional, but with where everything's optional. So you're still going to get deep attribute value checking, both at the top level and at the deep level. So if you, like in that previous spec, if you check whether things are valid, these first examples here are all true. They have partial amounts of the attributes at both levels, and that's fine. But it is getting checked to make sure that an ID is an int and the first and the last names are strings. And if those aren't true, then you'll get an invalid for that. Schemas gen, so you can gen examples of these schemas with all the attributes and everything. They also support unqualified keys, so we're trying to increase the support for things like JSON and things where you might be getting maps that have keys that aren't qualified, don't have that stuff constrained. So the schema can take a map of from unqualified attribute to spec in line. That can be nested as well. And you can then sample over that, check that for validity, and do all the normal things you do with specs. And then if you want to use the schemas in some context, so if you're looking at things that are going into or out of a function, you can create these selects that are more constrained versions. So a select is a combination of a schema, which here we're just reusing one of the user schema that we used before, and then the selection pattern. So a selection pattern in this case is the vector that starts with ID, address, and then a map of address to a vector of zip. And so what this is saying is that in this particular context, we require ID and we require an address. Address is a nested structure, so inside that nested structure, we also require the zip code. So if somebody who's going to go check the movie times near us, we need the zip code, and we also need to know who the user is because we're in some application. So those are the two things that are required for this context, this function or application that we're building. And then we can check the validity of that. We can get explains and just treat it like normal spec. You might have a different context, same schema, but some different selections. So maybe if we're going to place an order for movie tickets, we need to know their name so they can pick it up, and also their address because we're going to take payment from them, that sort of thing. So it's a different set of selections. We can check a different set of things, but we're reusing the same schema. We're still playing from the same set of attributes that represent a user in our application. So that stuff is all in there in Spec 2. Another thing that we spent some time on this year was closed spec checking. So a lot of people have run into this this thing where they want to make sure that maps don't have any keys other than the ones that are in their schema or keys. And open maps are a really important concept for us, both in Clojure and in Spec. We're not giving up on that. So, but there are definitely contexts where you want to be able to do that more constrained check. You might be on an API call where you're either sending something to somebody and you need to and we know that it's not a flexible API and that we can only send it these things, and if we send it other stuff it will break. Or we might be taking stuff in like in a configuration file or something, and if there's extra stuff it probably means the user mistyped something or is doing something wrong. So we ended up in a design where all of the conforming operations like valid and conform and explain now take a settings map, and so you can see on the slide it's the close setting map that's about halfway down. The only setting that's there right now is closed, and it takes a set of schemas that are closed for the scope of this call. So basically, those could be nested as well. I think there are some sort of convenience features we might also do, like some way to just close all schemas or close them per namespace or something like that. So there's some other conveniences that might come in there, but this is sort of the nascent feature. So this says basically, normally extra attributes are okay, but here in the context of this valid call, I want to close the schemas and only make sure that the attributes that are actually specified in the schemas are being used. So that is in there. Another thing that we spent a lot of time on at the beginning of the year, this is actually the first thing that we worked on, was making the specs more clearly symbolic. And so Spec 1 has this sort of language of spec forms implemented as macros that take a mixture of either nested spec forms or evaluated objects. So if you drop a function in there in Spec 1, like a anonymous function, it's going to actually get evaluated to a function object, and then Spec 1 is dealing with sort of this mixture of objects and forms. The macros were sort of required to make all that stuff work, and so that makes it difficult to programmatically construct specs. So we sort of went back to the drawing board on that kind of stuff, and Spec 2 more strictly separates the notion of symbolic specs that are just in sort of this form land and don't have any objects, and then spec objects, which is actually what ends up in the registry, things that implement the spec protocol and that you can call these different functions on. So Most of the things you do in Spec 2 are the same, but there are some corners of it that now you need something a little different. You need to wrap like a set set, I'm missing something else, set or something else, predicate, I guess. You might need to wrap that into a spec form if you're going to use it at sort of at the top level of one of these API calls or something like that. It doesn't really affect, it affects a lot of demos because you're doing stuff that's real simple, but it doesn't in general affect most of what you're doing with in real code from what I've found. So let's see, did I get through all this stuff? Oh, I did mention all this stuff. So resolve spec is a new function that actually, it's sort of a new, somewhat internal API. It's usually not something you're calling directly when you're just using the API, but it's something that's available for you if you're trying to do symbolic type stuff as a sort of dynamically generating specs and using them. So resolve spec is the thing that converts from a symbolic spec to a spec object. The spec forms are macros that expand to a call to resolve spec. So the spec forms are a little weird in that they are both a syntax for a spec and they are macros that expand to something that resolves that. So don't think about that too hard. And then it also became useful to split out. So def is the macro that installs a spec in a registry, in the registry. So it became useful to have an underlying function, which is called register, that lets you register a spec object. And so it's not doing any of this symbolic spec to spec object conversion. So, so the tools are all there now to actually be able to do all sorts of stuff. You can programmatically build up symbolic specs if you want to. It's just a matter of making the right forms. That kind of was there before, but now it's a little more strict in how all of that stuff works. And so it's a little more cleaner across the board in that regard. If you do that, you can call resolve spec. That creates an object which you can then use register with to register it into the registry. And you can do that by using no macros at all. So this is something that's ideal for doing sort of dynamic spec construction and registration. So this example is basically using cons to construct a spec or form from some data, and then using resolve spec to get a spec object. And at that point, you can just use it like any other spec object. Even though I've programmatically created it without any of the spec macros, you can call register to put it in the registry, and you can get a form back for it, even do all that stuff. So that's useful for a lot of stuff. There's also a helper called defop that I spent way too long on because it's a macro that generates macros, that's too much cleverness, but necessary in this case. Doing the hard work so you don't have to. So this allows you to basically take a sort of parameterized spec form and define a new, basically expand the spec form vocabulary, and it does all the work for you of filling in all the internal bits and pieces that need to exist for that to work. You just basically give it the spec form, and you can drop in, if you're referencing things that look like args that are coming into the op, those turn into, the proper things happen for those to make it into the spec object. So here's just an example of being able to create a bounded string that has min and max length on it. So bounded string is now part of the spec library. So once you've done this defop call, so you can just call bounded string 120, and that gives you back that's something you can put in the registry as a spec. So it allows you to build up a lot of patterns, and I found this to be really useful in practice for a lot of different stuff. Another big thing that we're kind of in the middle of right now is trying to come up with an alternate form for specs. So one thing that a lot of people have struggled with is like, once I have a spec, how do I programmatically manipulate it? Like if I've got a spec that happens to be a set, how do I add a new element to that set or something like that? And so we actually have built a whole parallel universe of symbolic map forms, and you can actually register specs as either the map form or the more classic op form. This is exactly what the syntax of that is. I mean, it's going to be a map, but exactly how the attributes work and that kind of stuff is a little bit still a work in progress. And we, in particular, have really been looking at ways that we can sort of automate. Right now, there's basically a dual definition happening for everything, and so we're looking at ways to sort of automate that away a little bit more. This opens up a ton more options for being able to manipulate specs programmatically. So there's all sorts of things you can do with it. And it's kind of spiraled into a broader set of things that we want to do. So some things that are still in work, like I said, we're more on map forms. We are probably going to be reworking how function specs work, how the ret fun specs work, probably some way to mix whatever gets replaced there back into defn, or some other additional macro that allows you to specify both the function and the spec together. We will definitely get to looking at metadata and doc strings. I know that's the highest rated enhancement in the issue tracker right now. One thing that we've definitely run into this year is open enumerated sets. So like keys has this issue with locking you into a fixed set of attributes, and you want it to be an open set that you can make choices about later. Enumerated sets actually have the same problem, that you might have a set of keywords, but you want to be able to add to it later. And so that's an area that we want to have better support for, and I've definitely run into that a number of times. And then things like spec traversal, and there's other ideas out there, but I suspect if we get through a chunk of these, like we might call that releasable at that point. All right, so I'm going to return from my detour here and talk about design a little bit, but I'm going to talk about some of the stuff in spec that we just did. So then the first place to start is really be intentional, and this is something you've probably noticed, is that we are always trying to be intentional about how we spend our time, what we work on, what we prioritize, and this sets the stage for everything else. If you're doing something that doesn't matter or is the wrong thing, then it doesn't matter how well you're doing it. It's going to be waste. So just thinking about what you're doing seems obvious, but something we could all do more of. Clojure has several pages of rationale. I don't know if you've read them, but you should read them. They're actually really good, and I think lay out a lot of Rich's ideas for why Clojure should exist and why it continues to exist. And they're 10 years old, and I think they're just as good now as they were then. Spec has a rationale too. So why do we always want to put this emphasis on rationales? Because we want to stay connected to the problem that we're working on. Rich is relentless about hammering this home almost every day. So you get down into the weeds of some thorny problem, and you're kind of figuring out, like, hang on, let's stay connected to what's the problem space. Like, what are we trying to do for a person who's actually using this thing? You have to always keep that in mind. So it's a matter of coming back to that. And you really want to be sort of thinking in problems, not thinking in solutions as much as you can. When we are thinking about how to solve things, tables are our number one tool for thinking about stuff. So we use them to enumerate alternatives, enumerate trade-offs, enumerate details. We really write almost no sort of doc, like text. Everything is in terms of tables. And so we have lots and lots of Google spreadsheets with lots and lots of tabs. This is an example one for when we were working on the closed spec stuff that I was talking about. And there's actually many tables in here embedded in one sheet, and this sheet goes on for another couple pages below this. But kind of just thinking through different aspects of the problem, and sometimes we're making choices, and we might color things to say, like, this seems good, this seems bad. Or we might decide, no, we're not doing, like, there's questions embedded in here, and we're saying no, like, we decided not to do that. So Rich and I have really it's taken a long time to figure out a way to work together remotely and really think collaboratively in a design space. And we found this works for us both, as ways to think about things. So if you're not using tables in your design process, I would urge you to try to do more of that. It's really a great way to think about things. Here's another one of us. This was things we were working on for error reporting for Clojure.main, which is one of the things in 1.10.1. But it's just us thinking through things. It's always important to remember that doing nothing is an option. So again, no is temporary. So you can do nothing, and then still decide to do something later on. It doesn't cut you off from that. Another big thing with design is taking things apart, being able to reduce coupling, reduce entanglement. I'll refer you to Simple Made Easy by Rich about that. I'm not going to say anything that he didn't say better, so I'm not going to talk about that much more. One thing I just ran across recently was this sort of philosophy from Gunpei Yokei, who's one of the designers at Nintendo and designed the Game Boy and other stuff at Nintendo. And their design philosophy was lateral thinking with withered technology, which I think is a fantastic phrase. They were really trying to see, like, don't use the latest technology, use the really dumb, obvious technology that is super cheap, it's very well, established, but then think of ways to combine things in new, novel ways. And so I think this, and Jack's talked about creativity before, I think this is one way that creativity happens, is this sort of combining things that haven't been combined before. A lot of creative things come out of that. And I think the use of analogy is another really critical aspect of this. And you see Rich is a master of analogies, and you see those at the conveyors in Core Async, or the maybe sheep and the choose a phone, and you've heard all these metaphors, right? And he just comes up with these off the fly every morning on status call, so he's good at it. Another thing, and I almost did the whole talk about this, is this notion of working from sort of one shared picture of the system. And don't take the one too literally. There's always more than one picture, but it is often, it seems to be the case, that there's one picture that allows a group of people to actually communicate and share that headspace and decide what they're actually working on. And this is sort of my current picture for working on Spec 2. I'm not going to go through all this, but there's a lot of interesting things there, and a lot of it, all the things I've been talking about with symbolic specs and spec forms and spec maps and all that stuff is in here, and it helps me really organize my thoughts and talk to Rich and have discussions about this picture, things like that. And it works in other domains too. This is actually John Coltrane's one-page manuscript for The Love Supreme. Does everybody know Love Supreme? It's an amazing jazz piece, right? It's a half-hour piece, 4 movements. If you look carefully in here, you can see Roman numeral 1, 2, 3, and 4. All 4 movements are in here. All the important parts of it are in here. So it's a really cool picture. If I can share it later in a way that you can actually go look at it more closely. But when I saw this, it blew me away, because he had it all on his head in one picture. And you thought I was going to get through the talk without an XKCD, but you're wrong. He did a bunch of these great things that plotted characters versus timeline and saw how they all matched up. And I'm not going to blow that up and look at it, but you should go check those down. Those are fun. I also ran across this one. It was about Catch-22, the book by Joseph Heller, which is about satirical World War II novel. It doesn't have any consistent chronology. It kind of jumps around in time a lot. But the one thing you can kind of hold on to, if you've ever done this in English class or something, is that they talk about the number of missions he's flown. And so you can use that as sort of an anchor. And you can't see it on here, but I think the left side of this table is the number of missions flown, and the top is the characters. And so he had this all mapped out. He was writing it, jumping around all over this chart, but he had the mental model that kept him on one page. This is the first transducer diagram I ever saw from Rich when it was brand new to me. It's got a lot of I'm not going to go through it all because we're getting low on time, but it's got a lot of those pieces in it. This is the prepl doc. This is basically the full design for prepl and everything, all the different aspects of it. So eventually we'll get around to actually docking that. This is Tools Depth's CLJ picture. This is out on the Clojure org site. Kind of has Tools Depths in the context of Clojure. So we've done, there's a bunch of different examples here, and I think it's really important to think about how you can try to make that one picture. And if I was going to summarize what we as a Clojure design team work, how we work, it's really these core points. Being intentional about what you do, staying connected to the problem, using tables to explore things, and making pictures to talk about the architecture and the overall system. So that's a key thing. And sort of my final lesson is, and this is something I think about all the time. It's just one of those things that comes up to me all the time. But everything that I think is like really truly valuable in my life or gives me pleasure is something where there was a lot of effort put into it. You know, it's raising my kids or learning an instrument or whatever. You know, learning to program or whatever. Solving easy problems is easy, so anyone could do that. Solving some or doing something that's harder is where the value happens. And so when something seems hard, that's good. That means you found a good thing, right? It is important to be intentional though, and not pick a hard thing that's hard just because it's hard, but pick a hard thing that's actually useful and work on those problems. And one of the things I value about the Clojure community is that people work on those hard problems. So, and for me, Clojure gets out of the way and lets me work on that stuff. Thanks everyone. Go solve hard and important problems. So.